Hey there, Miss Harper here for the Quadratics test review. Alright, I'm not going to go over this top part too much because I think you can easily look back into your notes to find examples of these things. Let's see, one thing I did want to point out though is remember this acronym, ROXS, rocks, okay? Remember that stands for roots, zeros, x-intercepts, and solutions. So these guys should all look pretty similar. And the quadratic parent function is y equals x squared. And if we want to make a little sketch of that, he's pretty cute. He has a vertex at the origin, and he looks a lot like that. And I think that's it. I think y'all are happy and good to figure out the rest of those. Alright, let's shimmy down here and start looking through these problems. Let's look at number 2. Which quadratic equation best represents the parabola shown below? Alright, so we got some options. Right off the bat, is this a positive graph or a negative graph? And the way I remember or tell my students is if it looks like a sad face, it's going to be negative. If it looks like a happy face, it's going to be positive. So this is obviously a negative parabola, so my leading x squared needs to be negative in order for that to be graphed that way. So I can automatically eliminate answer choices A and B. Now from there, I just want to go and match up some points. And actually, I'm just going to be lazy and go plug these into my calculator. So I have negative x squared plus 5. Alright, and if I go back and look at this, I can clearly see that the vertex is at the point 0, 5, right? And it looks like, so let's see, this would be x squared, actually let's just go into the calculator and do this. Alright, x squared plus 5, negative x squared plus 5. And then I'm going to go look at my graph, and I'm going to see which of those two graphs, either C or D, has a maximum at 0, 5. So I'm going to go second trace to find my maximum. Remember, you need to move it just to the left of the vertex, just a little bit to the right of the vertex, and hit enter once more. And remember, anytime you see this E pop up here, that just means 0, 5. So that one is actually looking pretty good. His vertex is also at 0, 5, but I just want to double check this other guy. So y equals negative x squared plus x plus 5. And go look at my graph again. And let's see, this one looks a little shifted, just barely. So let's double check and see what his maximum is as well. So to the left of the vertex, to the right of the vertex, enter again. So this one's actually saying that my maximum here is almost at 0.5 or 1/2 and 5.25. So I can see that that vertex, so his is about this, 0.5, 5.25. And that doesn't actually match the graph that I had listed over here. Alright, so use your calculator, use your y equals to your advantage. Now also I could have done, to find my vertex, x equals opposite b over 2a. And if I had tried to do that on this one, opposite b would be negative 1 over 2 times negative 1, which is negative 1 over negative 2, which is positive 1/2. So I can see right then that my vertex wasn't going to be at 0, 5, like I needed it to be. So he's gone, and C is our answer there. Alright, number 2, a quadratic function is given. What is f of 2? Remember, what is this 2 in place of? Hopefully you think x, right? That should usually say f of x. If it's in place of x, that reminds me to plug it in for x. So I would have y equals 3 times 2 squared minus 2 plus 6. And I could just plug that into my calculator. Let's see, so that was 3 times 2 squared minus 2 plus 6. And I get 16. So 16. Another healthy way to do this is to go into your calculator again, go to y equals, plug in your function, 3x squared minus x plus 6, and we can go look at our table. So we were trying to find when x is equal to 2 and see what the corresponding y value is, and we can see again that that's 2, 16. Cool. Number 3, which equation will produce the widest parabola when graphed? All right, so widest. So we have learned about our transformations. Remember, the greater, so anything, if our a value, the number attached to your x squared, if that's greater than 1, the bigger he gets away from 1, or the greater the bigger the number is, the, let's say the skinnier he's going to be. And the closer he is to 0, the wider he's going to be. All right, so these numbers that are getting like -6, that's pretty far from 0 or 1, and 2 also. So those are actually going to be skinnier. But let's compare these, and really what you could do is plug them all into your graphing calculator if you wanted. So I'll just do that, 2x squared, and then let's compare it to c, -0.6x squared. So I'm just, -0.6x squared. All right, let's go look at our graph. So I'm comparing letters A and C. So there goes A, and maybe here goes C. So already I can tell that C is far wider than A. So I'm glad I eliminated answer choice A. B is just going to be even wider than A. So let's go and compare C and D and see which one's going to be the better choice there. So I have 0.2x squared and -0.6x squared. So let's go look. So my first graph that comes up is going to be 0.2x squared. So 0.2x squared, and here comes the other one, 0, that's the -0.6. So we can see that the blue graph is much wider, okay, and that was the first graph that we entered, which is the 0.2x squared, okay. So yeah, all right, next one. All right, number 4. All right, number 4. The graph below shows h, the height in meters of a rocket, versus the time in seconds after the rocket is launched. From the graph, what conclusion can be made about the flight of the rocket? All right, so let's just go. Okay, so again, they're shooting a rocket. It looks like it's starting right here. They shoot the rocket, and it comes all the way back over here just after 4 seconds. All right. It looks like up here it reached a maximum height at about maybe 16-ish. All right, so let's look at our answer choices. The rocket reached its maximum height after 2.5 seconds. So let's go see what happened at 2.5 seconds. So this would be 2.5 seconds. And is that its max height right there, where it meets right here? And no, we can see it actually reaches its max height right over here, which was at 2 seconds. So it's not going to be A. B says at 0 seconds, the rocket was 2 meters off the ground. Well, here at 0 seconds, it does look like it started at 2 meters off the ground. So I'm going to put a little maybe right there. C, the height of the rocket was 0 meters when launched. Well, I don't see it starting here at 0, 0, so I'm going to say no. And then D, the rocket was in flight for 5 seconds. Well, we already looked and saw that the rocket landed right here before 5 seconds, so it didn't quite last 5 seconds. So B would be the best answer choice there. Number 5, which of the following is the vertex of the graph? Well, let's just go ahead and do this one by hand real quick. Remember, your vertex formula is x equals opposite b over 2a, where a is equal to -1, b is 2, and c is 3. So I'm just going to plug that in and have x equals opposite b, so -2 over 2 times a. That is -2 over -2, which reduces to +1. So that's the x value of my vertex. Well, we just need to figure out which one is the y value. Actually, and just by eliminating answer choices, we're kind of left with C, but let's just double check. Remember, to find that y value, we plug it in for x. So I would have the negative of 1 squared plus 2 times 1 plus 3. So just plug that into your calculator. We would have the negative of 1 squared plus 2 times 1 plus 3. And we can see what we get there, and we get the y value of 4. So y equals 4. And that would be our vertex, so yes, C would be our answer there. All right, number 6, what are the solutions? What are solutions? Remember, solutions are just another word for those x-intercepts. So what are the solutions to this? Well, I can't do anything with this unless it's set equal to 0, right? So I need to first subtract both of these things over to the left side to get everything on the same side of the equation. So I would have 2x squared minus 5n minus 7 equals 0, right? We took everything from the right side and switched it over to the left side. So now I'm just going to go ahead and, let's see, remember you can't do factor by grouping to find your two roots. I am just going to go ahead and plug this into the calculator. And remember how we do those. Actually, let's just do this. Why don't we plug this in? So we have 2x squared minus 5x minus 7. And let's go look at our graph. Since we have multiple choice options here, we could probably use this. Oops, I think I did something wrong. Okay, sorry about that. Forgot my x. I hate the computer calculator. All right, so look, we can pretty much visually see our roots. And since we have nice multiple choice answers, why don't we just kind of look through those? All right, so negative 3.5 and negative 1. So negative 3.5 would be over here. Do I have a root crossing there? No. But I do have one at negative 1 and 1, 2, 3, probably at 3.5. So negative 1 and 3.5. Negative 1 and 3.5. I see that right there, letter B. Okay. Remember, you can also do second trace in here, and I'll refresh you real quick on how to find one of your zeros. So 0. All right, so you move your cursor up here to the left of the x-axis, and then we're going to move it just below, and then hit enter one more time, and we can see it gives us the 0, negative 1, 0. All right, and then you could do the same thing over here to the right side, but I'll let y'all figure that out. Number 7, which of the following polynomial equations represents this graph? All right, so be careful because there's actually a scale involved here. Here's my origin, and then we see it goes to 4 and then 8. So that means this value right here is 2, this is 6. And same over here, so it would be negative 2 and negative 6. So be careful for your scales. And all right, so options, we could plug these into our calculator just like that if we want. But if we remember, whenever we factor these things, whatever we get for our last two factors, we take those things and we set them equal to 0, right? And then we end up getting the opposite value of those. So let's see, if I set this top one equal to 0, I would get x equals, well, how do I get this 6 over there? I subtract it, right? So I'd end up with x equals negative 6. I can see that my two solutions that I need, I have the 2 points negative 6, 0, and the point positive 2, 0. So according to what just happened over here, I end up with kind of the opposite value here. But right here I do see x equals negative 6. What happens if I set this x minus 2 equal to 0? Well, I would add 2 to both sides, and I end up with x equals positive 2. And that actually happens to be negative 6 and positive 2, the two roots that I was looking for. Okay, this one would give me a root at positive 2 and positive 16. This one would give me a root at 6 and negative 2. And down here we would get negative 2 and negative 16 for our roots. Okay, so hopefully you guys can visually see that. And then our last one is number 8. Given the function y equals this, find the given information. I'm going to go ahead and do all of this one by hand. It's pretty easy. So to find our axis of symmetry, remember we have our formula, x equals opposite b over 2a. So our b value here is negative 10, and our a value is 1. All right, so opposite b, I have x equals the opposite of b. I have negative 10, so now it's going to be positive 10 over 2 times 1. 10 divided by 2 is 5. So that's my axis of symmetry. Remember that your axis of symmetry and your vertex are related. These are the same x values. So to find that y value, we're going to plug in for x to our function. So we have y equals 5 squared minus 10 times 5 plus 24. And you can just plug that into your calculator. So that was 5 squared minus 10 times 5 plus 24 to see what the y value is. And we get -1 there. -1. All right, to find our zeros, remember we have to factor and solve. So I'm going to do that over here. X squared minus 10x plus 24. Since my leading term is a 1x squared, I'm going to use my shortcut. All right, I'm just going to find those two numbers that multiply to 24 and add to -10. And so it could be 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Well, I could see that it could be maybe between these two. However, one of these would have to be negative to add to 10. And that wouldn't make a positive 24. So what we're going to actually get here is -4 and -6. So taking my shortcut, remember you just plug those up against your x. I get x minus 4 and x minus 6. Again, that only works when this is a 1x squared, so don't forget that. Once we do that, we set our factors equal to 0 and then solve for x. So I would add 4 here. I'm left with x equals 4. And I would add 6 here. I'm left with x equals 6. So that gives me the two zeros of 4, 0, and 6, 0. The domain, remember your domain is always going to be all real numbers. All real numbers. And then our range, you could plug this into your calculator to go look, but remember that the y value of your range comes from the y value of your vertex right here. So this is a positive graph. It's going to open up. My vertex is at 5, -1. So therefore it's going to be anything greater than -1. My y value is going to be anything greater than -1. All right, guys, that's it. Good luck on your test. Go see your teacher if you need extra help.